Welcome back, class. This is the lecture number 4 of electrochemistry third, and in this particular lecture we will discuss about the types of electrode. Types of electrode. So starting with the very first, that is the metal ion electrode. Metal ion electrode. Now what happened in this case? Metal strip is kept in contact with the solution. Okay, so whatever metal you are taking, the metal strip is kept in contact with solution of water soluble salt which contain cation. So here, very simple. Suppose you are taking zinc as electrode, so the solution is of zinc sulfate. So the cell reaction is zinc solid to zinc plus plus aqueous, and the reaction, zinc first it is oxidized with release of 2 electron, then this 2 electron is gained by zinc plus 2, so this will convert it into zinc again. So this is the oxidation and this is the reduction and this is the cell. So this is very simple electrode. Next, and which is very important, is the hydrogen electrode. Standard hydrogen, sometimes it is also called standard hydrogen electrode. She, very common name is She. So standard hydrogen electrode, this is an standard electrode for many metal ion electrode. What is the setup for this electrode? So let's discuss the setup first. So this is here and this is the platinum wire. This we have taken the platinum wire. Okay, from here we will insert the hydrogen gas at 1 atmospheric pressure. This is the 1 m H plus solution. You can take any H plus. This is actually a glass electrode. This is glass, and this one is the platinum wire. And this is foil covered with platinum black. hydrogen gas at 1 atmospheric pressure and 298 Kelvin temperature. That means this is the pure and standard conditions. So this is what the setup of hydrogen electrode. The cell reactions, how the cell reaction will proceed. So the cell reaction for the oxidation at anode, hydrogen gas, this is the hydrogen gas, this is converted H plus aqueous with twice and a release of 2 electron, and reduction at cathode. So this 2H plus with 2 electron will convert again into H2 gas, and the cell reaction will written in this way: hydrogen with platinum wire is converted into H plus aqueous, and is then in H2 gas. So this is what the cell reaction, half cell reaction for both. The value of EMF, the E cell value for this is 0, and this is what the reason the hydrogen electrode is taken as a standard electrode, because compared to this we can calculate the other EMF of different metal electrode, but it has some limitations also. Limitations, what are that limitations? First limitation, well, it is very difficult to maintain this atmosphere of 1 atmospheric pressure and standard temperature, difficult to maintain. Okay, 1 atm and 9 to 98 Kelvin temperature. Second, it is cost. It is very costly because of the use of platinum wire. Okay, we cannot take other metal wire because hydrogen or hydrogen like salt can easily react with that metal. Okay, so the cheaper metal cannot be taken here, and for this we'll take the platinum wire, and this is what the reason it become a costly. Okay, so other metal can react with the H plus. So this 2 is the limitation for the hydrogen electrode, but still uh, the hydrogen electrode is vastly used as a standard electrode for many reactions. Now we are moving for the third, and that is the Calomel electrode, which is very important. Calomel electrode. Calomel electrode. So the Calomel electrode is also called Hg2 Cl2 KCl electrode. Mercurous chloride KCl. Okay, this is very important one. Calomel electrode is very important, and we'll first discuss its arrangement. What is the structural arrangement it looks like? So let's discuss that first. The structure of the Calomel electrode. In this case, we are taking the this is what the setup is look like, the Calomel electrode setup. This is the standard. this is a side tube. Okay, this is a side tube, and from here this is the whole setup is a glass tube setup. This is a glass tube, and this is a side tube. Again, in this we will take so here we'll take this is the KCl solution. Okay, KCl. Here you can take picture in your book, it is all given more clear. So this is the KCl. Okay, and this is the paste of Hg and Hg2Cl2, and this is nothing but Hg. Okay, and again this is the platinum wire. This is called band tube. So this electrode is actually what? Mercurous chloride electrode. In this case we are also using KCl. So this KCl concentration and the value of electrode potential is vary. So let's take these values. So at standard condition, that means at 25 degrees Celsius, if we take the concentration of KCl concentration and the electrode potential. So the KCl concentration and the electrode potential value, here I am writing at 25 degrees Celsius, 0.1 N, then 1.0 N, and then the saturated. This is the saturated. Value of electrode potential is 0.335, 0.281, and this is all this you always given whenever you are going to calculate. This will given to you. Okay, this is the deci normal, this is called deci normal, this is called normal, and this is the saturated. So these are the values of KCl at a different concentration. Now the very important, and that's it, that is the electrode reaction. So again, first at cathode, what will happen? Reduction is occur. So Hg2Cl2, this is the mercurous chloride, release of 2 electron. This will give 2 Hg and 2 chloride ion. At anode, what will happen here? Oxidation occur at anode, reduction occur at cathode. So 2 Hg and 2 chloride ion, the reverse will take, this will give Hg2Cl2 and 2 electron. and the cell, the setup of cell. So KCl, whatever is the concentration, here I am taking the saturated concentration. Then the Hg2Cl2 solid, and then the Hg is liquid. Okay, it is not a solid. So this is how the Calomel electrode looks like. Calomel electrode is very important. We will take one of the application of Calomel electrode, so that one more thing you should know, that in case of hydrogen electrode, this is the hydrogen electrode. So hydrogen electrode is reversed by H plus ion. What? Hydrogen electrode is reversible with respect to H plus ion. You should note this point. I'm writing here, hydrogen electrode is reversible with respect to H plus ion. Okay. In the previous lecture, the second lecture, we had discussed about the reversible and irreversible cell. Okay, so the hydrogen electrode is reversible with respect to H ion, and the Calomel electrode is reversible with the chloride ion. So the Calomel electrode is reversible with respect to chloride ion. So this you need to keep in mind. Got it? Let's take some of the advantage. What are the advantage of Calomel electrode? Then we'll take one of the application also. So the advantage of Calomel electrode is very important to discuss here. Advantage: it is easy to construct. Easy to construct. So transportation is very easy. Okay, construct, then transportation is easy, and handling is easy. So this is very important thing. Second, and one of the important thing, no need of salt bridge. No need of salt bridge. And the third one, the potential of electrode. Potential of electrode remains constant. This is again very important. So these are the very few and important advantages of Calomel electrode. Now let's take one of the application also. Application of Calomel electrode. This is used for to determine the standard potential of standard potential of manganese Mn plus 2. You can take concentration of M2 Mn electrode. This is very important. So how this will determine? What this we need to determine? So we will take this as the Calomel electrode as a standard. So we'll first construct the cell Mn plus 2 1m, then KCl Hg2Cl2 with Hg. Okay, so this is the construction of cell. This is the Calomel electrode, and this is the electrode which we need to identify the value of E, and with the help of this formula, E cell E of Calomel, that is the right hand side, minus E of Mn. Okay, so this we need to identify it. Once you know the value of cell, you can easily find out the value of this Calomel electrode. We know the value, the cell value given, so this you can calculate. So this is for the application of Calomel electrode. And the last one is the Redox electrode, the fourth one. Redox electrode. So what the redox electrode said, in this electrode an inert metal like platinum, you can take, which is very important. Platinum is dipped in a solution containing ions of active metal, containing ions of active metal. Okay, so in two different oxidation, in two different, this is very important, oxidation state. That means it's same metal but it has two different oxidation state. Let's take the example, like we have platinum, and then we'll take Fe plus 2 and Fe plus 3. Similarly we can take platinum, Sn plus 2 and Sn plus 4. So what the cell reaction takes happen, simple, Fe plus 2, Fe plus 2 is oxidized to Fe plus 3 with the release of one electron. Okay, so here the oxidation takes place, and Fe plus 3 then again lose one electron to Fe plus 2. This is the reduction. So this is how the oxidation reduction takes place with the same metal, and this is what the redox electrode. So here in this particular lecture we had discussed four different types of electrode. First was the metal ion electrode, very simple. Then hydrogen electrode, which is also called the standard hydrogen electrode, which has some limitations also. Here the hydrogen electrode is reversed with respect to H ion. The third one was the Calomel electrode, which is also called Hg to mercury, mercurous chloride, KCl electrode, which has different values, different electrode potential values at different concentration. And this Calomel electrode is reverse with the chloride ion. Okay, this is the cell reactions we have. Then the last we have some discuss some of the advantages of Calomel electrode. These are the advantages along with one application. And finally we have a redox electrode in which same metal is taken against a inert metal like platinum, which has both oxidation and reduction occurs. So as the examples of Fe plus T. Okay, Fe plus 2 and Fe plus 3. So this is all about from this lecture. Thank you.